on a second.
We still have 3 minutes actually until our official starting time, so we can figure out the audio for the streaming. Maybe we have to wait a little bit until my voice comes. There's a little bit of a delay. Is it good? Okay. All right. All right. So I was saying, my name is Paul Ionescu. I'll be presenting for you some of the content in the morning. I'm a security architect at Trem Micro. At Trem Micro, we make software that protects software. So there, I'm in charge with make sure our product is secure. I'm also an ethical hacker. So what does that mean is that I'll look for security issues in software and exploit them, but for good purposes. And I'm also a part of the OWASP Ottawa team, along with Garth and Nancy and Dave and Scott and Abdul. And Sharif is going to join us a little later. So I'll talk to you about OWASP in a bit as well. I'm very passionate about software security. So how many here are software students? Awesome, awesome. So glad to see you here. So you're probably learning about software. Well, definitely learning about software. But I'm not sure how much you learned about software security and security aspects of software yet. So at OWASP, this is our mission, to educate people about software security, because software powers the world. And if we are making sure the software is secure, we're securing the world. So that's why I joined OWASP, and this is why I also created the Secure Coding Dojo OWASP project. So the Secure Coding Dojo is a training platform for educating developers about software security, and you'll get to play with the Secure Coding Dojo in the second half of our workshop. So as the recording will be available afterwards. So as I was mentioning, the OWASP Ottawa, or OWASP, is about securing software. OWASP stands for Open Web Application Security Project. We have monthly meetups in Ottawa at Shopify and Trem Micro. So at our meetups, we present and we have talks about various subjects related to software security and security as well in general, as well as DevOps, security, and many other things. And we have a group of an audience about 1,000 people that are registered on our meetup group. We have a Twitter account. So if you're interested in software security news and getting updates on software security and finding out what's next on our presentations or the next event that OWASP Ottawa is organizing, you can follow our OWASP OWASP_Ottawa Twitter account. And many of you have already joined us on Slack. Thank you for that. And so the link to join Slack is listed there as well. I also wanted to talk about Secure.Cert, which is a co-organizer to this event. Secure.Cert helped us organize registration, Eventbrite, and you have talked to Nancy. She is representing Secure.Cert here. Secure.Cert is a study group in the Ottawa and Gatineau region. And it organizes training with subject matter experts, and this is where we leverage Secure.Cert expertise to organize this event. And the goal of Secure.Cert is various industry security certifications. And you can follow Secure.Cert on Twitter too if you're interested. And then we also have two big sponsors that we have to thank. First of all, obviously University of Ottawa for providing the location and logistics, and Miguel, thank you so much for putting this together and helping us. And then Trem Micro is hosting the Secure Coding Dojo project. And actually, Trem Micro, it is a Trem Micro project that Trem Micro open sourced. So Trem Micro is a big supporter of this project as well. Okay, so speaking about Trem Micro, I brought you some swag and info sheets and business cards. So if you're interested in an internship or a job at Trem Micro, you can find it over there. We have some nice stickers too. That was my plug. Okay, so this is the agenda. This is what the plan is. We've done the registration. Coming up, we have a presentation of common software attacks, and then we are going to go over Security Code Review 101, where we review security best practices. Then we have pizza, and then in the second part of the workshop, we get to play with a very vulnerable application and exploit it, conduct some hacks on it. And also, we're going to get to review some code samples to find vulnerabilities. And 4 o'clock, end of workshop. All right. Any questions before we get started? Washrooms are on the same floor, by the way, if you need them. So I was told that you go this way and then that way, and you'll find them. Okay. So attackgrams. Attackgrams, a visual journey into common software attacks. So I thought is a good idea to get you started with some, to introduce you into the concepts of software vulnerabilities and exploits with some diagrams that I created. And there's about 24 or 25 different diagrams that we're going to take a look at. They represent different attacks, and so that's going to introduce the concepts of the things that we hear of software attacks and vulnerabilities all the time, and it's what it makes our computers insecure, makes our data that we store online insecure, right? And we're now starting to understand them more. And so the first one in the list is authentication bypass. So authentication bypass is a type of vulnerability where the application is missing authentication for a sensitive area. Can anyone give me an example of authentication bypass that we hear a lot about in the news? Phishing? Phishing is more of a targeted attack. Somebody will send you an email and trick you into clicking something. It's related to buckets. Yes? That's right. We're changing the URL to get directly somewhere. But what we hear a lot in the news is that this and that company had an unprotected S3 bucket. Okay, an S3 bucket is an Amazon service, S3, the simple storage service. And many companies use S3 buckets to store customer data, but they make these buckets public for some reason, and then attackers can navigate to that link directly and obtain the data from the bucket. In spite of the application needing authentication, the attacker will navigate directly to the page that is not supposed to be accessed publicly and obtain that information. So that's authentication bypass. Okay, so the question was, would Google hacking be included in this category? I would consider Google hacking more of an information disclosure type of vulnerability, um, or unintentional information leakage. Uh, this is the S3 example is the applications actually leverage those buckets, right? So they interact with those buckets, and the development may have thought at some point in time they were protected, and then they made them public. So it's practically it's a software vulnerability. Here's another one: reliance on untrusted inputs. Okay, so reliance on untrusted inputs occurs when the software uses client-side security controls. What do you think? Is client-side useful to enforce security controls? No, because the attacker can modify the client side, right? So a lot of times what you're going to see is the application has some variables that are used in a security decision, whether the user is an administrator or not, or if it has permissions to this page or not, and it stores those in cookies or query parameters in a URL, and the attacker can simply modify those, change true to false, and get access to restricted functionality. Missing or incorrect authorization. So we talked about authentication bypass. In this scenario, it's a very similar type of attack, but the application does enforce authentication. The difference is that the application now has multiple roles. It has maybe an administrator and a limited user. And the vulnerability here is that the limited user can access the administrator functionality, and the application fails to prevent them from doing that. So there's a mistake in the way roles and permissions have been implemented. And you can see in the diagram that the attacker gets access to the limited UI, and then they forcefully browse to the administrative UI. And many pen testers actually do so. They'll log into an application and they'll just change the URL to admin, or they'll fuzz to various things to try to get this type of access. Next one is missing encryption of sensitive data. So let's assume your database or your user information did get stored publicly and attackers got access to it. Let's assume that information had passwords. Okay, if those passwords were in clear text, this adds insult to injury, because what we're hearing now is a lot about credential stuffing. Credential stuffing is the practice of attackers hacking a less secure site, like maybe an entertainment site or some marketing site, and they'll take your password from that site and use it on a more secure site like Google or Microsoft, and log in or your banking site, and use that credential. So that's why they always say don't use the same password everywhere. So the best practice here, and this is considered a vulnerability, is storing a password in clear text. Can anyone tell me what is a better practice for storing passwords? A salted hash. Very good. Yes, that's right. So transform the password. Transform the password so it's not reversible. Use of a broken crypto algorithm. So cryptography is hard. There's a lot of situations where developers have chosen to roll their own cryptography. Do you think that's a wise decision, to write your own cryptographic module rather than using OpenSSL or something else that's been battle hardened? So that's the category of use of a broken crypto algorithm. Another aspect is sometimes cryptographic algorithms become outdated. The researchers find vulnerabilities in them. MD5, the example in here, is an outdated hashing algorithm. And what has been uncovered is that if you use MD5 to verify file integrity, you create collisions. Okay, so a collision means that file A and file B both produce the same hash. So an attacker with enough computing power could replace a file with malware with the same hash as a valid file because the MD5 algorithm is not secure enough. And that's a deprecated algorithm. You should not be using MD5 when you develop your applications. I don't know what just happened here. Unsalted hash. So I really like how you said salted hash, okay? Because that covered two things at once. So hashing, making the password not pseudonymizing the password, making the password not be what it actually is. That's the hashing. But salting the hash with something that is unknown to the attacker, and even if it is known, it would take a lot of computing power to generate. Makes the hashing better. So has anyone heard of rainbow tables? Okay. Rainbow tables are pre-computed hashes. Okay, so there's a site called crackstation.net. We're going to use it later. This site allows you to look, to take a hash and look for it and see if it's been pre-computed already. And they pre-compute numbers, known strings, dictionary words. And then if your password was weak, like for example here, A, B, C, D, E, F, G, that's a password that is weak. They will be in the rainbow table. So it doesn't matter, if you hash it with a stronger algorithm than MD5, it can still be reversed. Password guessing. So this one's the easiest one of all. And we hear about it in the news. Have you heard of Guccifer and Guccifer 2.0? So Guccifer was a hacker that was not technically inclined at all. Actually, he was used to be a taxi driver, and he broke into accounts of famous people in the U.S. like Colin Powell and others, and released classified information. And then Guccifer 2.0 was used by Russian hackers to cover their tracks when they interfered in the U.S. elections. The Guccifer 1.0, all he did was he used password guessing and also used password reset, like password security questions on websites. And that is very easy to do. Many people will use well-known passwords like 123456 and others, or date of birthday, and then attackers can use that password and get their account. Very easy. No need of knowing how to write shell code or exploit all kind of server-side vulnerabilities. And the most interesting part is the application itself. The main vulnerability that the application has is that it did not make you have a stronger password, did not enforce that password. Because you've seen many applications preventing giving you an indicator of your password strength. Integer overflow. So integer overflow, that's a very interesting one. I've heard about it in the news that they had to recall or do urgent fixes on a Boeing plane a while back. We know Boeing planes had more issues since then, but I know this specific case was about an integer overflow. So they figured out that after some point in time, the counter they used for some functionality of the avionics would reset to -1, which could have had unintended side effects. Okay, so when you use a counter in a security decision, like for example, max account login attempts. Okay, if somebody is using, if an application uses a max attempts type of integer, and let's say it sets it to 5. If the attacker keeps trying for many times, they will eventually reset the counter if the application is vulnerable to this and be able to still log in, because the counter will be less than 5 if it's -1. So that's integer overflow. Download of code without integrity check. So we download lots of software, right? Download applications on your phone, download applications on our computers. How do we know that software is safe? Right? So if we download an application from the internet and we just run it, we have done this vulnerability. Sometimes the operating system is checking for us. Sometimes the operating system, like you will see the operating system say, this developer certificate is not verified, doesn't check out. So that's when the operating system protects you from this vulnerability. So most of the times, integrity checks are done, and this is the safer way to do, with an RSA signature, with a digital signature, where the software has been digitally signed. If you don't do this digital signature verification, then it's a download of code without integrity check. And if the application itself does updates, downloads updates, and downloads a new version of itself without doing this check, then it's a download of code without integrity check. And what does this protect from? It protects from a man in the middle that is either in the middle on the network connection or in the middle on the customer, on the infrastructure, on the download server. And they replace the software with something bad. The digital signature keys are very safely guarded and can prevent malicious actors from conducting this type of attacks. Open redirect. So we were talking about phishing, right? So open redirect helps with phishing. So when you get an email from a phishing attacker, you'll see something like, oh, your bank account has been locked out. Click here to reset your password, right? And you look at the link, and the link says, got some weird random digits in it, and it maybe they try to make it look like RBC or like other banks, right? They include that in the name because they try to trick you. So it'll be like rbc.123.io, okay? Something like that. But if RBC had an open redirect vulnerability on their website, they could just use the RBC website to redirect you to their evil page. And the URL you got in your email will be actually rbc.com site. You'd trust it. So that's what open redirect does. It allows attacker to leverage a trusted site, trusted.good, to redirect to evil.bad. Cross-site scripting. Have you heard of cross-site scripting? Okay. All right, so cross-site scripting is another type of client-side attack. It's also used in spoofing, in phishing. And it's an attack that allows cyber criminals to insert arbitrary scripts in a website. They can insert it in the link, so they can make that insertion in the link they send you. That's called reflected cross-site scripting, or they can store it in the site, and that's stored cross-site scripting. So imagine you go to Reddit, okay? To Reddit, you comment on a thread there, and you enter a script in the thread, in your comment. If Reddit doesn't properly encode that script, that JavaScript code will execute for everybody seeing the thread. So that's an example of stored cross-site scripting. Now, that code can change the behavior of Reddit. Reddit can now upvote your post, or there's been a very famous worm. What was it called? I forget. But they were using MySpace. The Sammy worm, exactly. That's right, by Sammy Kamkar. That's right. It was using MySpace to replicate itself and was using cross-site scripting. Thank you. Cross-site request forgery. Cross-site request forgery is another type of client-side attack. What happens with cross-site request forgery? Well, I was giving you the example of your bank. Here, the attacker usually leverages a website that can store a link in it. They can also use an email, a phishing email. But imagine your bank has a page on it that transfers money, where you can transfer money from one account A to account B. If that page is vulnerable to cross-site request forgery, the attacker can store that link either in a trusted site or send that link to you in an email. And then if you click that link or you go to that page, your browser will use your credentials in your cookie store to authenticate you against rbc.com and execute the transfer. Okay? So if you're logged in one tab in rbc.com, and then on the other tab you go to the site that had the link injected in it, that site will execute the transfer transaction under the covers. So that's why don't have other tabs open when you do your online banking. Upload of dangerous file. All right, so what happens here? An attacker, there's a file server where you can upload various things like documents. OneDrive. Okay, so you can upload documents to it, but imagine you can upload a PHP file or a JSP file to it. PHP, are you guys familiar with PHP? Okay, so if you uploaded a PHP file, what would that allow you to do? Especially if you could navigate to that page after, and that page would go through the PHP processor, it will execute, right? So this is how this upload of dangerous file works. You would upload a web script or other dangerous type of file, and also called a web shell. And it's being used a lot on PHP sites, actually. That's why I gave the PHP example. So next one, XML external entities. And I know we have a lot of them, and I'm going quick through them, but don't worry. In the second portion of our workshop, you're going to get to execute each of these on the vulnerable website. So XML external entities. XML external entities allow you to embed content dynamically into an XML document. Okay, so you'll have something like ampersand, variable name, colon. And if you put that in the document, you can embed things from the file system. So don't ever allow XML external entities, right? Because an attacker will embed this, and they can insert, if the XML document is used to process a response or render a response, they can, for example, insert sensitive system files into the XML by using one of these XXC variables, or they can make the XXC send the variable to a third-party website. Path traversal. So path traversal is also known as a // attack. Right? So sometimes when you're coding, you need something from a directory higher up. You're going to do // You know, maybe you want to look at some text file. You do a cat // the name of your file. So this can be used against applications. If a website or web application doesn't have the proper security measures, attackers can obtain sensitive system files. So for example, here, users will download file.txt. The attacker will go to //secret.txt, get out of the application directory, and obtain that file arbitrarily. We only have a few left. OS command injection. So this one is very, very dangerous. OS command injection allows you to piggyback malicious scripts when programs execute shell commands. So you can imagine you have an application that verifies internet connectivity by using the ping command. Have you ever seen screens like this? Put in the host you need to verify internet connectivity to, and you get a ping output. Do you know what kind of, where did you see it? Can you give me an example? If that looks familiar to you. Speed test sites? That's a good example. But there's one that you should, your router, right? When you configure your router, there's a diagnostics page there. Yeah. So you can go and you ping a website to see if you have internet connectivity to it. And you'll see the output, ping, ping, command, ping. And this vulnerability, OS command injection, is found in routers a lot. And it impacts IoT devices a lot. So practically what happens here, the attacker will put in the host, ABC, and then they'll embed a bash script afterwards. They either put a semicolon or they'll use the tick. And so then what happens is that command is split in two by the operating system. One of them will do the ping, the other one will do what the attacker wanted to do. Okay? Because in bash you can add multiple commands, you can pipe them, you can put semicolons, and if the application doesn't do the correct things, the input validation to prevent this type of attack, then it is possible. Another type of injection is SQL injection. SQL injection a lot used in data breaches. This is when applications will take the user input and concatenate it to an SQL command. Okay, so if the vulnerability exists, the attacker can inject multiple SQL commands, and then instead of having one SQL command execute, you have two SQL commands execute. And in this example here, the attacker did a select from the table, from the users table, where the username is J Smith, and then they also inserted drop table users. What does drop table users do? Deletes the table, right? Yeah. So so that's SQL injection. Insecure deserialization. So deserialization, we hear about it a lot in Java application. One particular Java third-party component or open source library, I should say, is Apache Struts, and it's been known to have a lot of these deserialization vulnerabilities. And so deserialization attacks are very dangerous. They allow attackers to execute code just like with the command injection. The only difference here is with the command injection they would execute bash scripts. With deserialization they execute Java code. And deserialization exists in PHP as well, to be fair, and other languages. So practically what happens is the attacker will send a command object, and the regular user will send like a regular object. Like in a library application or bookstore application, they'll pass in a bookstore Java object in binary format, while the attacker will send a special type of object, special type of class that allows executing code. All right, we have two more. Buffer overflow. So are you familiar with C programming? How many C programmers do we have? Okay. All right, so buffer overflow is specific to C applications. It allows attackers to cross variable boundaries, so overflow the buffer, and go into other variable space or even program code and execute their own code, also known as shell code. Buffer overflow and other type of memories attacks are very impactful. They also allow the code execution, and this time the injection of the code is in the bytecode of the software, the binary code of the software. And you hear about it a lot in 0 days that impact browsers and operating systems, right? Things like, I know Chrome, if you haven't updated your Chrome has a 0-day vulnerability that I heard about on Friday. So check your Chrome and update it. It was used, and so buffer overflow is very powerful because if the attacker can attack the operating system and make the operating system execute their code, they don't need any privileges on the system. And if you navigate to their page, you may think you didn't click on any bad links, that you didn't do anything bad. But if your browser is vulnerable to one of these memory vulnerabilities, then it will execute the code without you even knowing. Format strict injection allows attackers to leak program memory by passing unexpected format strings. So again, a very common in C applications and in logging functionality, where the application takes the input from a user, puts it in a printf, and writes that to a log, and maybe the attacker can get the logs. And so they can extract memory with this vulnerability. And they can extract things like your SSL keys from the memory, which then would give them much more access. So this was a very fast, accelerated journey through various software flaws and exploits. I think we're on time. It's 11:06. Next, I'm going to go into how to prevent these exploits, because we saw, okay, what are the exploits? We maybe kind of understood, right? What did developers need to do to prevent the exploit? But we're going to spend a little bit more time on it now. Before we do that, any questions about the exploits we've seen? Okay. So I am not going to go into all the things that a developer can do to prevent software attacks. Some of the things can be done in the framework. Some of the things are just done once, set it and forget it, and then you're good. Other things come up all the time. And I'm going to spend the time on those, the things that come up all the time to prevent vulnerabilities in applications, the ones that give you the most bang for the buck. So these are the input validation, using parameterized commands, safe functions, indirect object reference, encrypting data, safe memory management, and neutralizing output. All these prevent a whole bunch of the attacks that we have just seen. Okay, so and they're very likely to come up when you write your code, and when you start writing code at a company and you do a code review. These are the things that would come up in a code review, that you're missing your input validation or you're missing neutralizing output. Okay, so these are things that you want to be well aware of. starting with input validation, the most important and the easiest way to reduce attack surface. Okay, so I have an analogy that I use here all the time. I'm asking people to think about their house and whether they would allow anyone to come into their house. Would you allow anyone to come into your house? Likely not. Okay, you wouldn't keep your door open. You have some sort of validation, right? Some either look who knocked at the door, have a key to allow certain people in. So it's same thing with inputs. If you develop an application is like a house. Your application should not allow all the inputs to come in, all types of input. They should only allow the inputs that are necessary to come in. And another thing that I've seen in applications is block lists. Block lists are a type of validation, right? And they are a type of software defense, but they're inefficient. There's always a way to bypass them. And to that analogy, would you keep a block list of who's not allowed to come into your house? Like, okay, keep a track of all the criminals in your city that they're not allowed to come in your house? No, you know your family and friends are allowed. Anybody else? No, don't let them in. So it's the same idea with your software. You should use allow lists, not block lists. So I have a challenge for you. I'm going to give you 2 pieces of code, and I'll ask you to spot the input validation problem. So you can tell me if it's top, bottom, both top and bottom, or neither. Both of them have a problem. Okay. Can you tell me exactly why?
You're allowing the user to insert unsanitized whatever they want into a shell code. So they could simply use a semicolon to exit the current command and enter a new command or whatever they want.
Yep. And that was what type of vulnerability? OS command injection. Thank you. That was awesome. Very good. Let's give him a round of applause. Good job. Okay, so yes, the input is unsanitized. This is a command injection, very well spotted, and the bottom has no validation whatsoever. The top has block listing, where the application is only blocking semicolon. Yeah. Okay, so how about now? So the top one is the only one vulnerable. Yeah, that's correct. That's correct. The alpha num only allows letters. That's right. So that the answer is correct. The top is the vulnerable one. Special characters are not needed. We saw in those code examples how special characters can cause trouble. Many parameters type. If you look in your browser debugger, if you do a F12 in your browser and look at the network tab, and you look at all the things that your browser is sending to an application, majority of those are alphanumeric. Okay, they're either you have something that is true or false, you have a session ID, which is a hexadecimal number, you have sometimes a host name, which is alphanumeric with some punctuation, but many parameters are not even intended to contain Unicode characters, right? So the isAlphanum function or exception that we were using earlier to prevent that command injection is very simple. And I mean, this is one example of the function. You can design your own. But you could just have a simple function that checks that the input is alphanumeric. And by the way, this function here will work for French language globalization support as well. Special characters in French language will be considered letters. Okay, so it doesn't need to be an ASCII. Don't need to worry about supporting foreign languages. And you can add an exception too, because sometimes you need to allow some types of punctuation. And so that's a simple function. You can have it in your software and you can always use it. Apply it to all the inputs that you know are going to be alphanumeric in type. And this is a Java implementation, but you can make a very easy implementation in your language of choice. And it's multi-purpose. So these are the type of inputs that we've seen a lot. It will validate Boolean types, ascending, descending, numeric, hexadecimal, and host names. And if we were, I never actually wrote a mathematical function to calculate it, but I think you can write a mathematical function to measure the impact of input validation on the security of a software. And I think the more input validation you have, the more secure the software, the less vulnerabilities you have. Okay, so if you use input validation as a stopgap measure, what do? You reduce the attack surface. There's less things for the attacker to go after. Right? So in this diagram here, you have the input in yellow, the number of vulnerabilities in red, and the amount of input validation done in white. So the more input validation, the less vulnerabilities. Now the thing is, before we go there, an input validation from all that attack list that we talked about prevents 1, 2, 3, 4, 5, just straight up injection attacks. Both SQL injection and command injection are prevented by input validation. There's a bunch of other injections as well. Path traversal is prevented by input validation, because if you only allow alphanumeric characters, you can do the ... right? Cross-site scripting is prevented because you can't put script tags. Open redirect is prevented because if your input is alphanumeric, you can put URLs. You can put HTTP : // Deserialization is prevented because if only alphanumeric is allowed, you can put base64 encoded objects. So it is very powerful countermeasure. It's your insurance policy against vulnerabilities in your code. Now, imagine you have a name parameter and you do alphanumeric validation. Then Irish people can't use your application anymore because an Irish name has O'Brien, right? It has a quote in it. Quote, by the way, is used in SQL injection a lot. So if you were to prevent from SQL injection with input validation, you couldn't allow Irish names in your site anymore. So that's not acceptable. There you actually have to allow it. So not everything can be protected with input validation. A lot can be protected with input validation. All your alphanumeric types can. And we have established that a lot of the input that your application takes in is an alphanumeric type. But while input validation reduces the attack surface, it cannot prevent all attacks, and we are going to talk about some more countermeasure to prevent other type of attacks where input validation cannot work. So to sum it all up, input validation reduces the attack surface and prevents many types of attacks. Block listing is a bad practice. Many input types are alphanumeric, and for those input types that need special characters, we need different defenses. Before we move to the next one, any questions? Oh, good. All right. So, I have a sentence for you that I want you to remember. Concatenation causes injection. Okay? Concatenation of input coming from a user with a command, if it's an SQL injection, an SQL command or an OS command, doesn't matter, it will cause injection. Because the attacker will replace the input with another command. So then you have two commands. That's injection for you. And it also rhymes, so you can remember it easily. And what prevents injection is parameterized commands. And what happens with parameterized commands? Well, your command interpreter, your program, interacts with your command interpreter, and it says, this is the command and these are the parameters. And so there's no way to alter the commands that go to the command interpreter. The command interpreter sees the command as a constant, and then it interprets the input separately. So then even if you have special characters, you can't break the command. And before we go to the next challenge, can anyone give me an example of parameterized command call in Java? Java SQL. Prepare statement. Yes, that's right. Thank you. All right, so let's play spot the injection. Which code is vulnerable? Top or bottom? Sorry? Top is vulnerable? That's right. And so the bottom, you see the parameterized, right, concept. You have command arguments, right? So you have, in the top, there's concatenation, right, where you have command processor plus cping plus update server, and then that gets passed in. And then the other one, you have command arguments where the command is separated. This is the command, this is the argument, and then that goes to the command processor. That's why this is parameterized, and this prevents OS command injection. Now, granted, if you have to execute shell commands in your Java calls, that's an insecure practice. If you had a better way, right, like to read the file or use some Java functionality to achieve the same thing, you should use the Java functionality, not call the bash, because that's called shelling out. No, so, and it's an insecure practice. But if your application is shelling out and you have no other choice, then this can prevent, this with input validation can prevent the vulnerability. How about the next one? Top? It is top. Top is the vulnerable one. Because replacement in a string is also concatenation, right? So the top practically does a string format which replaces the user's input into the query. The bottom one is using those question marks and a prepared statement. Okay, so that one is safe because those question marks and the setting of the arguments here, you see, this is where the application is setting the arguments. That's a parameterized command call. Just want to talk about ORM frameworks, or ORM frameworks if you prefer. ORM stands for Object Relational Mapping, And some example of such frameworks are Hibernate. And what these frameworks do, they abstract the SQL stuff from the programmer. All you do is you work with POJOs, Java objects, and the framework takes care of everything for you. You're just going to put something in the store, get it from the store, the framework converts that into the SQL statements, and the framework itself can be built to be secure and only use prepare statements. So, to sum it up, parameterized commands handle situations where hazardous characters are needed. Yes? Yeah, yes, there have been. There's always bugs in third-party components. In everything, there's bugs. So the question was, have there been any bugs found in Hibernate before where SQL injection was possible? The answer is yes. But they have been fixed. ORM frameworks prevent mistakes. And it's always, what I suggest is when you implement parameterized statements or when you interact with the database, always use parameterized statements. If you can use an ORM framework, use an ORM framework. But always use input validation as well to double your defenses. Right? So for some inputs, they have to be risky. But it's always good, if you know the input is alphanumeric, I can't repeat it enough. Use input validation as well. All right. Problems with memory. And that's not just because we're getting old. This is because we always had problems with memory. Okay? Since computers have been invented, we had problems with memory. And because of memory allocation in C++ application, the way developers work with C applications was to allocate memory and calculate the amount of memory to be allocated. And there was been possibility to have defects in the code because we have the possibility to have defects in the code with everything. The defects in the code that had to do with memory allocation are security vulnerabilities for the reasons we spoke about earlier. And I'm going to talk about 5 of these vulnerabilities: classic overflow, incorrect calculation of buffer size off by 1, format string injection, and use after free. These happen to be also on the Sans Top 25 at some point. I think there's a new Sans Top 25 that has been released this year. This is a top of the most common software flaws. And in the C category, memory category, these were the most common software flaws. There are more type of memory vulnerabilities than those. So first I want to talk about the things that can prevent this type of attacks. And these are the safe functions. And they're not entirely safe, they're safer. So instead of using strcpy, you use strncpy. Instead of using getS, you use fgetS. And the reason why these are safer is because they can allow you to control the size of your input. If you didn't have enough, if you allocated a certain amount of buffer or a certain amount of memory, these functions allow you to control how much memory you're reading, and that only that amount of memory is being written. But an important note, if the buff size argument into these functions is larger than the size of the buffer, it's a miscalculation, incorrect calculation of buffer size, and you end up with overflow still. So just by using these functions doesn't mean that you're completely safe. You also have to calculate the buffer properly. So check the boundaries. Also, comparison operators can lead to off by 1 type of attacks. So instead of using a less than, you use less than or equal, and then your application in a loop ends up going 1 more than it should. So that's an off by 1 attack. It can cause crashes. And some other good advice: always use constants when allocating memory. Okay, if you don't use constants and you type in that's a bad coding practice, um, but also is in the secure coding practice. And memory injection. We talked about injection, right? Is there such a thing as memory injection? Yes, the format string injection is a type of memory flaw caused by concatenating, again, the user input in a format parameter. So let's take a look at some memory flaw examples. Can you spot the flaw and also tell me what it is? That's right. So the bottom one is the vulnerable one. It's using getS. It's not checking the length of the input. And what type of vulnerability this is? It's buffer overflow. It's overflow because you're overflowing the buffer. You're overflowing user pass. And it was a use of a dangerous function because getS is a dangerous function. How about this one? I didn't use a constant. That's right. I didn't use a constant. But which is, to get all the points, which is the vulnerable one? Top or bottom? Bottom is the vulnerable one, yeah. And it's an incorrect calculation of buffer size because I calculated that I need 5, but I read 9, and that I overflowed. How about now? Bottom one doesn't do concatenation. Well, it does a formatting. It's a printf with formatting. But it doesn't concatenate the user input to the format. This is constant. The user input here is a parameter. That's right. The top one allows the attacker to enter a format string in the user pass and exfiltrate memory. How about this one? Yes? That's right. The top one is off by 1 attack because it's less or equal. That's correct. Thank you. So to sum it all up, in the memory category, safer functions allow limiting the number of bytes read into the buffer. But even with safe functions, special attention should be paid to the size specified, or use a memory safe programming language. So what was it? Oh, that could be it. Very good, thank you. I wasn't aware of it, but thank you. So as I mentioned, there's more memory type of attacks. Okay, there's more stuff that we are focusing here. We're focusing on the on the most common ones, but there's other attacks such as use after free as well, and other type of attacks that you hear about. And I was going to say, use a memory safe language where memory is handled for you. You know, things like, what's your favorite one? You pick. Java. Java is, yes. Although Java is slow sometimes and need to do the garbage collection to clean up the memory. But but that's right. It is memory safe. There's no buffer overflows in Java. So sometimes you can't avoid it. C is going to be something you need to do because you're writing a system driver or you're writing something that is very low level. And when you do that, remember the memory. All right, next category, and we got a lot on this slide, is about securing data. Right? So what we hear about lately is people concerned about their data, right? Either their Facebook data or their other types of data being misplaced, exposed in S3 buckets, personal data being traded on the darknet. And this is such a big concern that the European Union has created a law to handle with this problem. Have you heard of GDPR? How many have heard of GDPR? Awesome. That's a very good number. I heard about it very much, and many software companies have heard about it because customers in Europe have asked software providers to show what are the safety measures they put to protect data. So it's serious. The government is very concerned about it, and they put big fines if they find that the company did not do enough to protect the data. So data should be transmitted and stored securely. Before I have that at the bottom, but I'm going to say it now. If you can avoid storing the data, if you don't need the data, I know developers love data, okay, but we can do so much with it. But if you don't need it, if you don't really need it, don't store it, don't collect it. Okay, that's the best countermeasure of all. But if you do have to store it and collect it, remember that cryptography is one of the most important measures. You also have authentication control, logical access controls. But cryptography can be used to mitigate attacks. Using secure protocols for transmission of data, things like TLS 1.2 and TLS 1.3. Using secure ciphers in the TLS protocol. Perfect forward secrecy is a concept that is implemented with secure cipher like ECDHE to make the data, the session encryption keys, ephemeral, only work for a specific session. This prevents against government or nation states collecting large amounts of data and then running cracking attacks or extracting the private keys from the server and decrypting the data at a later time. Strong digital signatures. We talked about MD5. A digital signature generated with MD5 is not safe. A better class of algorithm is SHA-2. Rejecting invalid certificates. So when you write your code, a lot of times you're going to create an API call or a URL request, and it's an HTTPS request, and your server is a test server, doesn't have a valid certificate. So what do? Do you write some code to ignore the validation error, or do you import the server certificate in your certificate store to trust it? So if you write that code to ignore it, even if it's test code, it may end up delivered. You may forget to remove it, and then your application will not really use your communication because any man-in-the-middle attack is possible. It will ignore invalid certificates. Strong authenticated symmetric encryption in transit and at rest. Okay, so When you store the data in a database, use strong encryption algorithms. A key of 256 inside AES is the algorithm that is used most of the time, and GCM is a type of a blockchaining that is being used to that is more secure than things like ECB, which is a way of doing AES encryption, but can still allow attackers to detect patterns in the encryption of the data. So those are the best practice recommendations to secure data. Let's spot the data breach. So let's take a look at this code. Where's the data breach? That's correct. That's correct. That shows that code doesn't really show you, what a storage or what's happening, but it shows you that the password is compared in clear text, so it means that the application has the password in clear text. Okay, and that one is, it's a vulnerability, but it's a harder vulnerability to exploit than the vulnerabilities that we're looking at here. And sure, timing attack, but we're focusing on the data protection. Okay, so we're looking for the password to be salted and encrypted in the database. And disclaimer, these code samples are not the most secure code samples that you're gonna see. So I expect to find more vulnerabilities in them. So thank you for that. Okay. How about this one? Okay, is that the only problem? Right, I was after that mainly. So just because it's using an HTTP the data is being sent in clear text, but as very well observed, the fact that the URL also has the username and password makes the password stored in the browser history, server logs, other places where you did not intend the password to be. So always send secrets and passwords in the body of a request, not in the URL. All right, how about this one? That's right. Which one is it? Top. Yes. So data is being put in an S3 bucket and encrypted. If you can see, it says CPAN, which is a term to describe credit card account number, personal account number. So it's credit cards being stored in an S3 bucket. So if the S3 bucket is unprotected and attackers get to the credit cards, it's what happened to Capital One, this? Okay. And they say it was a firewall misconfiguration. Okay. While the code at the bottom, there is encryption being employed, right? That crypto utils is doing an AES 256 GCM. But there's also a data cleaner that removes the credit card number from the data, which is even safer, right? because you just take it out. You can leave only the last 4 digits, I think, and just to identify what credit card was used, and remove the part that matters. So to sum it all up, avoid collecting data for individuals. Pseudonymize the data. Strong salted hashes can be used. Replace key data with star. Use strong cryptographic algorithms like the SHA-2 class, AS256, GCM. All communication should be encrypted. Use HTTPS. Data classification is risky, so when in doubt, encrypt all data. So don't try to, figure out, okay, this parameter needs to be encrypted, this doesn't need to be encrypted. Encrypt everything. All right. So next, we talked about cross-site scripting a little bit. Cross-site scripting is widely used, and it plagues applications all over the world. And it's a serious vulnerability. It's not as serious as SQL injection or command injection or buffer overflows, but it's a serious vulnerability, and it allows attackers to conduct spoofing attacks where they attack the users of an application. And it plagues all applications because HTML is good looking. There's a lot of feature-rich frameworks such as jQuery, React, Angular. UIs are responsive and versatile, and HTML is portable. You can use the same application on your mobile and on your laptop. So cross-site scripting is the ability to inject arbitrary JavaScript into a web page, and as we were talking about earlier, is reflected, stored, or DOM-based. It's easy to introduce, easy to find, and leads to data breaches with the spoofing attacks. And what you see here in the screenshot is an attack where somebody was testing a cross-site scripting vulnerability, and they inserted script alert with something in a URL, and the application responded with a pop-up. And this is very common, type of cross-site scripting testing technique. But an attacker wouldn't really display an alert. An attacker would replace the page with something else. They'll steal your password, or they'll just do something under the covers. So, defenses against XSS, input validation. Neutralize output. So, if you can't do the input validation, you need to allow markup. Then you can neutralize the output by using HTML encoded if the output is server-side generated, or using safer type of avoiding dangerous attributes like inner HTML and SRC, and using JavaScript frameworks like Angular, like templates where the JavaScript framework will take care of the rendering for you. And there have been vulnerabilities in jQuery and other frameworks that were related to cross-site scripting as well. So just because the framework is doing it doesn't mean there's not going to be a vulnerability in the framework, but it's safer than you doing it yourself. So this is how HTML encoding neutralizes cross-site scripting. So you have the user's input, you have script alert script. Then this is a Java call to HTML encode the input. The input gets encoded like this. Okay, you see the ampersand, LT, semicolon, and then the page rendered in the end neutralizes the script. The pop-up doesn't really execute. So let's take a look at some code samples to spot the cross-site scripting. Do you see it in this one? There's no escaping at the bottom, that's right. So the bottom one is the vulnerable sample. How about here? There's no escaping anywhere. The inner HTML is the vulnerable one, that's correct. The bottom one. You guys are good. How about here? Both are vulnerable? Yes, set timeout is insecure for sure. But what you have here is an example of JavaScript parameterized statement at the bottom. The input is being passed as an argument, and because it's being passed as an argument, it's being neutralized. The top, though, the input is concatenating, so it's a JavaScript, it's an injection, right? So the top one is the one that's really vulnerable. And I got one more. Here we have both examples have encoding. Well, they're both using a library. They're using the same library. Just the top one does something extra. It's something, yes, but it's something because the library itself doesn't have that protection. So I'm going to explain this one. Look at where the input gets inserted. It gets inserted where you have the percent equals search txt percent. Okay, so there, if you put in a quote, you break out of quotes, and you're right inside the JavaScript context. So the code here does an extra thing. It replaces quotes as well. And the bottom one doesn't, so the bottom one is vulnerable. All right, so to sum it up, cross-site scripting is easy to introduce and easy to find. Actually, attackers or pen testers, bounty hunters only need the browser to do it. Okay, so it's not as hard to find as buffer overflow. Buffer overflow is more complicated. Encoding should be applied to all server-side generated content. Additionally, encoding of single quotes sometimes in Java. Dangerous HTML context should be handled with care or avoided. And using a framework such as React.js, highly encouraged. Last one. I think we're almost at the top of the hour, but we're on time. So last one is indirect object references. So as the image shows, the attacker will try to go directly to the object of interest, but we're making them go through an intermediary, right? A hash map, or a dictionary of values. And so we're mapping one to the object. We're not allowing, imagine those are files on the file system. We're not allowing the attacker to obtain the file by name. They have to provide the ID of the file to obtain it. So that's what indirect object references do. And I have a path traversal example for you. The top one is vulnerable. That's right. So as you can see, the bottom one uses this available files list and uses the file ID to map to the file name, which, besides just preventing the attack also allows you to do input validation on file ID easier, because file ID is supposed to be numeric. So it has this advantage as well. So that was it for indirect object references. To sum it up, reduce the attack surface by enforcing access to objects through identifiers rather than actual representation. Identifiers can be input validated easier and also solve encoding issues. And that was it. Any questions? You've been an awesome audience. You spotted all the vulnerabilities right away and even found extra vulnerabilities that I didn't know they existed. And that goes to show you that it's always good to have a second pair of eyes as looking at the code. And so this is from a presentation called Security Code Review 101. So when you develop code, it's good to do code review, right? But if you include security elements in your code review, you can prevent security issues from lurking into your code. What else did I have here before we stop? Let's connect. So that's my Twitter handle, PentestQ. And you can also connect to me on LinkedIn. And I have some resources for you, and this will be available because the presentation will be available. The Secure Coding Dojo GitHub link. There is a series of articles on Medium that I wrote, Security Code Review 101, which go into detail of this presentation. Like pretty much is the material of this presentation, but in detail. And if you need to get back to it and consult it again, you can use this. The attack grams that we took a look at earlier are also available online, and OWASP. If you are developing software, OWASP is your securing software resource. Okay, so the OWASP website can help you in many areas, be it testing, secure coding cheat sheets, and many other things. Okay, so that was it. Garth, yes. This one, I think. Or
Thank Miguel.
Oh, well, I had already thanked Miguel. Thank you again, Miguel. We cannot thank you enough. Okay. And before is the pizza here? Okay.
But yes, we're co-organizers for this event. But to put answer, if you're a student, probably not the target audience. But if you're at work or trying to change career or to elevate your career with cybersecurity certification, we do organize study groups for them. So we do the CISSP. This semester, we actually did Security Plus. That's more entry level certification. And then with Rana, when we were at a bill, we are working on OSCP or penetration testing certification. We actually started with Pentest Plus, but it turns out that we're doing a lot more than that. So anybody can choose the certification they want, but we're basically learning about penetration testing. And we also did, we're doing the CISSP. So it changes every semester. If you decide to study on your own and you don't want to pay, and you haven't had the discipline to do that, or you don't want to pay thousands of dollars to go to training in a facility, well, think about Secure That Cert, because we're organizing groups pretty much every semester. So the best way to reach us is to follow us, to be on our meetup page, where we always tell you about this attack. But if you're in school, I think that's where you should. Thank you.
Thank you, Nancy. Thank you. Okay, so we're gonna break for lunch. Before we stop, can I ask you a favor? Can I take a selfie with you guys? Okay, because to me this is a very important event that OWASP Ottawa is doing, because we always intended to reach out to students and universities. This is the first type of event. Secure That Cert was so helpful, and Miguel, we're so thankful for helping us organize this. So I just want to immortalize the the moment. So everybody say secure coding. There you go. 1, 2, 3. I don't know. I don't know. I don't know why I have this this on either. Okay, let's go. 1, 2, 3. Okay. And I blinded myself too. Okay, so for the practice time, verify that you can access this URL, oas.trendmicro.com. You are going to need a Google account. If you don't have a Google account, sign up for a Google account. And that's it. We're just waiting for pizza as well. Okay, so while we're waiting for pizza, set up for the Secure Coding Dojo. Let us know if there's any issues. Garth and Abdul will help us as well. So you can flag them down, and you can flag me down as well.
And if you're concerned about